Hello and welcome to section 3.3, the derivatives of trig functions. So, usually when it's an in-person class, I require that students memorize these derivatives. With this being online right now, I can't really do that, but it's a very good idea if you know these derivatives. And in fact, in section 3.3 on Canvas, you'll see there's a link that says know these derivatives. And that is going to include all of the derivatives. We've done these: power rule, derivative of the square root, derivative 1 over x, derivative v to the x, the product rule, the quotient rule. Now we're going to be moving on to the trig functions and eventually the rest of these as well. So the better you know these, the much easier your life is going to be for the rest of calculus. Okay, then on to these. So the way that I do it is, first of all, I do sine, tangent, and then secant. The derivative of sine is cosine. Now you may wonder why I'm covering this up right here, and it's because right across from sine, I'm going to put derivative of cosine. The derivative of cosine is negative sine of x. So in a way, if you know this one over here, you almost get this one for free. Although these that say co, it means the co-function, all of the co will be, the derivative will be negative. The derivative of tangent is secant squared. And so across from that, I put cotangent. Because it's a co, it's negative. And because it's a co, it's not going to be secant squared, it's going to be cosecant squared. And then for secant, the derivative of secant is secant times tangent. Right across from that one will be cosecant. So again, because it's a co-function, its derivative is negative. And if this one is secant tangent, then this one is cosecant cotangent. That right there pretty much summarizes the new stuff in this section. Now what we need to do is take all of these new friends as well as the friends that we made previously, these derivatives and rules for derivatives, and then combine them. Let's start off easy though. Example number 1. Just y equals sine of x on the interval from 0 to 2 pi. Where does the derivative equal 0? Well, if you look at the graph of sine from 0 to 2 pi, it goes like this. Starts at the origin, goes up to 1, hits the x-axis, goes down to -1, and then it would finish right here at 2 pi. So for a horizontal tangent line, that would be, for example, right here when it gets to the top. So that would be a horizontal tangent line, because if the derivative equals 0, that means the slope equals 0, which means it's a horizontal line. And then aquí también tenemos dos. There's one right here, and there's one right here. So I can actually find out when does the derivative equal 0, almost without doing any calculus. Because if that's 2 pi, that means right in the middle, this is pi. And then this red one would be half of that, so it's going to be pi over 2. And this one would be 3 pi over 2. Now let's take the derivative and see if I actually did it right. So the derivative of sine is cosine. Then set that equal to 0, and it's saying when does cosine equal 0? So you could use cosine inverse and find out cosine inverse of 0, which I think I'll try it. So cosine, right now my calculator's in radians. because that right there says use radians. So I'm using radians. And then do cosine inverse of 0. And that should be pi over 2. To find out if this decimal is pi over 2, what I do is I go divide that. So just hit the divided key, divide it by pi, and then go to math and change that to a fraction. So that means that it's 1/2 of pi, or pi over 2. Now, using the calculator and saying cosine inverse will only give you one answer. Other answers you have to find yourself. So this equation right here is saying if you were to graph the cosine function, which I'm doing right now, then when does it equal 0? So this would go from 0 to 2 pi. In the middle would be pi. And so there's two places when it equals 0. One would be right here, and one would be right there. This one would be pi over 2, and this one would be 3 pi over 2. So sure enough, I did it right the first time. Pi over 2 and 3 pi over 2 are our two answers. Then how about something that is a little more challenging? Example number 2. How about if it's just y equals x squared times secant of x? So this is a product. We need to use the product rule. So the product rule goes, take the derivative of each one of these, but you can only do one at a time. So the derivative of x squared, that would be 2x, and then leave secant alone. The product rule has plus. Now leave x squared alone, and what's the derivative of secant? So then I have them memorized. The derivative of secant is secant of x times tangent of x. Now with this one, I'm not saying set it equal to 0 or anything. That is the derivative. But I would like to factor it, because this has secant, that has secant. They also each have x. So I could factor out an x, and I could factor out a secant of x. What remains? So this would only have a 2 that remains. This would have one x and a tangent. And there we go. That one is finished. Then for example number 3, how about if the function is tangent of x over x? So for this one, we get to use the quotient rule. So the quotient rule is going to have the bottom get squared. That's the easy part of the quotient rule. Then take the derivative starting with the top. The derivative of tangent is secant squared, and then times the x. Now you could put the times x right here, but then if I write it right there next to that other x, some people will think, oh, an x times an x, that's an x squared. But this x is inside of the secant function, so you cannot multiply it an x times an x and get x squared. So to stop people from having that confusion, then I put the x in the front. Technically, you could put it right here. It means the same thing. Okay, then the quotient rule has minus. Now I'll leave the top part alone. And the derivative of x is 1. Now with this one, there isn't really anything I could do to simplify. This has an x, but this does not. So I cannot cancel any x's. So in fact, that one right there, it's already done. Then for example number 4, how about if the function is e to the x times cosecant x? Then what's the derivative of this? You're right, we get to use the product rule. So using the product rule, you take the derivative of the first one, and the derivative of e to the x is e to the x, and then leave cosecant alone. The product rule then goes plus. Now leave e to the x alone, and next we need the derivative of cosecant. Well, the derivative of cosecant is negative cosecant times cotangent. And I just put the parentheses right here so that it doesn't look like it's e to the x minus it, because it's e to the x times it. And then when you put a little dot like this, sometimes the dot's so small, so just emphasize it by putting it in parentheses. And then I could just do a little bit of factoring. This has e to the x and cosecant. This has e to the x and cosecant, so we could factor that out. Oops, cosecant. And when you factor it out, this is going to leave behind a 1. And then this negative will be right here. And the e to the x has been factored out. The cosecant's been factored out. All that's left is the cotangent. And that is number 4. Then, for example, number 5, find the equation of the tangent line. For the function x times cosine of x when x is equal to 0. So when it says tangent line, that means you get the slope by taking the derivative and plugging in the number 0. We also need the y value. So if you plug in a 0, that's going to be 0 times cosine of 0. And because it's 0 times it, it equals 0. So we have the point 0, 0. Now I need the slope. So for that, find the derivative. And in order to find the derivative, do the product rule. The derivative of x is 1, and then cosine just stays there. Then the product rule goes plus, leave the x alone, and take the derivative of cosine, which is negative sine of x. So with these derivatives, what I usually do instead of having this giant piece of paper is what I usually do is put it on a 3x5 card. Whenever I need to learn something new, I still use like a little 3x5 card, put them all on there, and then you can easily refer to them. Okay, now I need to substitute x is a 0. So the derivative, when you plug in 0, will equal 1 times cosine of 0 plus 0 times negative sine of 0. So this is going to be 0 times something, so that's 0. Cosine of 0, that equals 1. So the slope of the tangent line is going to be 1. Then I can use the point slope formula. So y minus the y value equals the slope times x minus the x value. So y minus 0, that can just be written as y. And then this part right here is just going to be 1 times x. So y equals x is going to be the tangent line. Let's see if I did it right. So graph the original function. The original function was x times cosine of x. And then I'm going to zoom in to the origin because this is talking about the origin. So if I go from -2 to +2 and -2 to +2, then I can see what's going on at the origin. So we need the tangent line going through this point right here. So that would be a line approximately like this. And let's see if I got it right. So I got y equals x. And graph, does that look like the tangent line? It definitely looks like the tangent line to me. Here's another important thing about tangent lines. So this is the tangent line at 0, 0. So if you zoom in on that point, then the difference between the graph of the original and the graph of the tangent is going to be very little. The difference is going to be very little, or in other words, they're going to be very close. So right in here, they're exactly the same. Then as you move out, there's a tiny bit of difference, a little bit of difference, and yeah, then they're starting to move apart. But if you're close to the origin, the function and its tangent line are very, very close. Which means you could use this function to estimate this function as long as you're close to 0, 0. So for example, what about a 0.1? So if, before doing this problem, I said, how much is a 0.1 times cosine of 0.1? And you'd be all 47? I don't know. But this is saying that y equals x is going to be very close to the answer. So if I'm using a 0.1, then y should equal about a 0.1. So if I plug that in, 0.1 times cosine of a 0.1, and it equals a 0.1. Good job, tangent line. You did a great job. Now, how about for example number 6? How about for this one? Is it possible that the derivative equals 0? And the function is going to be cotangent of x. So first of all, find the derivative. The derivative of cotangent. Now, we actually end up using these three a lot more than, we use these 4 a lot more than these 2. So sometimes when I'm not sure about that one, I go back and go, the derivative of tangent is secant squared. That means the derivative of cotangent is negative cosecant squared. Negative cosecant squared. Then can that equal 0? Well, cosecant. So there's a negative, and then cosecant is 1 over sine. So that means this equals 1 over sine squared. And I can tell right there that there's no solution, because the only way that a fraction can equal 0 is if the top equals 0. Or another way to prove it is, what I could do is get rid of this fraction by multiplying both sides by negative sine squared. Multiply both sides by negative sine squared. On the left side, it's going to say 0 times something, so that is 0. On the right side, these are going to cancel. The negatives will even cancel. All that's left is 1. And it says, did you know that 0 equals 1? That is false. So y prime cannot equal 0. And one last one. Example number 7. So basically at the very beginning, I just said, here's these derivatives. But how could you actually prove them if you wanted to prove them? So we'll prove one of them. Prove that the derivative of secant of x equals secant of x times tangent of x. The way that I remember this one is that secant likes to talk about himself. So he goes first. He goes, yeah, secant, secant, secant. And then tangent goes, hey, what about me? Okay, prove that. So the derivative of secant of x. So first, I need to use a trig identity for secant. And that trig identity is that it equals 1 over cosine. Now, do the quotient rule. So the quotient rule is going to be, well, the bottom gets squared. That's part of it. Now start taking the derivative and starting on the top. The derivative of the top would be 0. Derivative of 1 is 0. And then times the cosine of x. Next it goes minus. Leave the 1 alone and take the derivative of cosine, which is negative sine of x. And then simplify this. So this is going to be 0. This is going to be a negative times a negative is a positive. So that means that it's sine of x divided by cosine squared. Ta-da! Well, wait, that's not quite done. Shoot. Okay, well, I'll just keep going. So the next step, cosine squared means you've got a cosine times a cosine. And sine can be rewritten as 1 times sine. All right, now look at this. This part says 1 over cosine. And 1 over cosine, that equals secant of x. And then this part says sine divided by cosine. And sine divided by cosine, as you remember from trigonometry, sine divided by cosine is equal to tangent of x. That is exactly what I was supposed to get. Please hold your applause until the end. Thank you.